Okay, U11IB, welcome to another screencast. This time we're talking quadratics. I've got a series of quadratic screencasts lined up for you. It's very exciting stuff. We'll get into some solving first. I think we'll get 4 videos out on quadratics, which will be our last topic leading into our exams in a few weeks' time. So quadratics is going to go over the next couple of weeks, going to lead us into exit. And then probably post-exit we'll just look at revision, getting ready for a set of exams. All right, so quadratics. This is not a new area for you. This won't challenge you too much in terms of your conceptually. There will be some new areas to look at, and probably what we'll do mostly is just get better at dealing with quadratics, quadratic equations, graphing, solving problems, etc. Okay, so we know that quadratics are power 2 equations, or polynomials of index 2, so highest power 2, and they have probably, of all the polynomials, we spend most of our time in quadratics, as it does lead to, because of the shape of the graph, it does lead to problems on max and min and things like that. So, alright, we need to be really good at quadratics. No, better than that, we need to be awesome at quadratics. So let's get awesome at it. First thing we need to, first skill, and this screencast is going to be on factorising quadratics. Or it's actually, well, we're going to look generally at solving. So this first screencast is really on solving quadratics. And there are, well, I can think of 4 methods. Sometimes it's our choice, sometimes it's not. So this is our first area, solving quadratics. Okay, so there's three main areas, methods. We can look at solving quadratics by factorising. So how are your factorising skills? It's going to be really important. By completing the square, and by using the quadratic formula, so use of the quadratic formula. Let's get that right out there. X equals minus b plus minus b squared minus 4ac over 2a. All these a's, b's, c's are talking about the standard form of a quadratic equation, ax squared plus bx plus c, or expression in this case. If we're looking at y equals that, we're graphing it. If we make that equal to 0, we're solving it. Okay, so three main methods of solving quadratics. Let's look to the first method, factorising. Solving by factorisation. Okay, so I want to get through basically those 3 methods of solving quadratics in this screencast. Can we do it? Okay, so let's look at an example. X squared minus 5x minus 14 equals 0. So solve that. That's the instruction. That's the task. Solve that. Righto. Don't expect there to be too much trouble with this. We're looking, but just so that we're right from the outset, we're not assuming too much. We're looking for 2 numbers here that multiply to minus 14 and add to minus 5. They're the 2. I'm going to take those circles away now because I don't like them. They're the 2 things. So multiply to minus 14, add to minus 5. What are those 2 numbers? Oh, let me think. Minus 7 and 2. Hopefully you got there faster than me. I'm sure you did. Those numbers now, right, because we know that this is an XX situation. Well, I have to lead with X in each bracket, and the minus 7 and plus 2 join in. So pretty simple stuff. Solving now, X is equal to 7 or x is equal to minus 2. I don't think I've challenged you too much there. I think that's probably all in place, and you've got some neural pathways that match up with what I've just said. Okay, so that's a straightforward one. That's straightforward because the coefficient of x squared is just 1. That makes that one easy. Let's have a look at another factorization where we have to solve 3x squared plus 2x minus 5 equal to 0. Okay, so what do you bring to the party here? Well, there's different methods. I think with a prime number out the front here, this thing here is called a coefficient. And because it's the coefficient of the x squared, which is the highest power, it's called the leading coefficient. Leading coefficient. Now, if the leading coefficient is a prime number, then I reckon we can probably, we know that it's a 3xx factorization. Hopefully you've picked up what I'm talking about. 3x times x, 3x squared. There's no other way of getting 3x squared. If this number is not prime, we'll look at that in a moment. There are different options here, in which case there's a bit of guessing and checking involved. But with a prime number, x squared, we're right into it. We know that these two numbers here have to multiply to minus 5, and when I do this and this, I've got to get plus 2x. Okay, so what are my options for minus 5? Well, really, it's 1s and 5s, isn't it? So to get plus 2x with a 1 and a 5, I'm going to have to minus 1 there, plus 5 there. How's that look? Minus 3x plus 5x gives me the plus 2x. So yeah, we're doing a little bit of guess and checking there, but I reckon it's a quick way of doing it. You know that 3x and x have to slot into those two spots. And you know that one's going to have to be negative because you need negative 5. So 5 and 1. So it's either going to be minus 5 and 1, 1 minus 5, and you just sort of fashion it. I know that and that have to get me that plus 2. So you just work it through like that. Look, if you don't like that method, if you prefer something a little bit more concrete, so a little bit more methodical, then you could go to splitting that middle term. I don't know if you've looked at this before. So redoing this question, just to solve this out now, x equals minus 5 over 3, or x equals 1. I'm kind of brushing over that, but hopefully you see here that 3x plus 5 equals 0, x minus 1 equals 0. What we do, just to get the method sorted out in our heads, we're really clear on this. Once we've factorized and importantly we're equaling 0 here, then what we do is make each of the factors equal to 0 and then solve from that. So 3x plus 5 equals 0, x equals minus 5 on 3, x minus 1 equals 0, x equals 1. They're the values of x. You see, if either of these factors equals 0, then the product is 0, and it's job done. Okay, so we've solved that. How about we look at solving it another way? 3x squared, see if you like this. This is kind of a nice method. It's logical. It'll do every quadratic in the world, so it might suit some of you. Here I'm looking for two numbers that multiply to not minus 5, but minus 5 times 3, so minus 15. Two numbers that multiply to minus 5 times 3 and add still to this number here, 2. So, alright, so get those numbers for me. 5 minus 3, how's that? Okay, but unlike with this question here where we just stuck them in alongside the x's, this is not quite so straightforward. What we do with the 5 and the 3 in this case is, let's get rid of all these squiggles. What we do in this case is we break up that plus 2x to 5x minus 3x. How's that look? Or I might have done it the other way around. It doesn't matter. Doesn't matter. Stress that. Whether I put minus 3x or plus, but I reckon I'll just team my minus 3x with my 3x squared, and my 5x with my 5. Now you see what I've done there? I haven't changed this, still the same quadratic, but I've split my middle term, my 2x, into minus 3x plus 5x. I've got those numbers from there. Now, I very cleverly kind of split this into two pairs and factorise in those two pairs. Take out the common factor of that pair there, it's 3x. Got x minus 1 in there. I now know, if I've done this correctly, that I'll get x minus 1 in my bracket here. Absolutely, look at that, that expands nicely. Now I've got 3x plus 5, 3x plus 5, x minus 1 equals 0. Yeah, look, that's the same. X equals minus 5/3, or x equals 1. Okay, that's the second method. That's all I'm going to show you. I'm not going to show you any other methods. Let's solve using that method. Just because I think if you're using this one, then you're probably going to keep using that. But would you use it for a 4x squared? For a 4x squared plus 4x plus 1 equal to 0. Are you going to do that? Alright, well I am. I'm looking for two numbers that multiply to 1 times 4. So 4 and add to 4. That's easy. That's 2 and 2, isn't it? So now that middle term there becomes 2x plus 2x plus 1 equals 0. I factorise this first pair, take out 2x, which is the highest common factor. It's now 2x plus 1 inside. Oh, I've got 2x plus 1 already, so I'll just put a plus 1 in there to affect that. See what's going on, can't you? It factorises to 2x plus 1. Oh, hang on, 2x plus 1 is a perfect square. So x is equal to minus 1 over 2. It's the same solution. So there's only one solution here. It's a perfect square. If I graphed it, it would be where it just bounces off the x-axis. Only one solution. I'll get rid of that graph because it's probably not correct. Okay, so we've solved by factorisation, and I'm now 12 minutes into my screencast. That's breaking all the rules. I've gone too long. So I'm going to stop that there, and I'll make another screencast for the other two methods of completing the square and use of the quadratic formula. Who knows, there might be separate videos for each one. I've obviously carried on too long, but it is important that we're able to factorise correctly and solve. Okay, over and out.